Hey folks, Lindsay here. If you are here from VITA and you're not interested in neural networks, skip to the next video. But if you are here and are curious about what I'm learning, this is what I've been doing. We did this one, structuring machine learning projects, and then we finished up this one too, convolutional neural networks. For the first one, structuring machine learning projects, we did a lot about splitting up your data. So you have your data coming in and how you want to split that to train on, and then for your dev, and then your test sets. Now that we have huge amounts of data, and if you're using a data set that has just massive amounts of data, it's not unheard of to do something like a split of 98-1-1. Then we also learned about precision and recall. So this is the month of VITA, vlog every day in April. So I'm going to use an example for that. Precision would be like if I type in VITA in a search box, how many of the resulting videos that come back are relevant to VITA. And then recall is that if I'm looking at everything on YouTube, how much of what is actually VITA is returned. So those are two different things, but you need to know those because then we go into performance. And a lot of times it's, can the computer predict like a human? So human level performance. It was a relatively short course, just 2 weeks I think. But the next one is all about convolutional neural networks, or CNNs. So CNNs get their name because you basically convolve your image data, which is, you can think of it like shining a flashlight over a group of pixels and then taking certain features from that grouping and putting it into another matrix, and that's called convolving. So you convolve your images, and then you run an activation function, typically ReLU, rectified linear unit, and then you will do a pooling. Currently, the vast majority of projects or models are using max pooling, and that basically just grabs the most important feature from the data. You run those three things over and over and over and over and over, and that's basically feature learning. So in the beginning it is very basic. It might learn like vertical line, horizontal line, just random, very basic shapes. So further on down the network, maybe you have something that's like, oh, these are eyes. So we have all these images that have eyes in them. And then further on down in the network, you might have something that's like, oh, this is attached to a human face. This is a dog face. This is a cat face or a bear face. But they all have eyes. And then it might start to realize, okay, this is like a golden retriever type of dog. This is a pug. This is a husky. So it basically goes from very, very simple to more complex features as you get deeper in the network. Then towards the end of the network, you want to start classifying things because you want to know, okay, is this a dog? Is this a cat? Is this a human face? Is this a dog face? So, residual networks, we learned about those, ResNets. Essentially, if you have a neural network that is very, very, very deep, it can start to lose accuracy. Adding more and deeper nodes further on down the line doesn't always make it better. When you backpropagate, so you basically tweak the things to say like, okay, we're trying to make this better, the things in the front affect the things further on down the network. And so as you tweak the things in the front, if the things further on down in the network can't find their minimum because things are changing too much. So instead you can basically hop over, it's kind of like a bypass. You can hop over some of the nodes and pass in that data further on down into the network to make it a little more robust. If that's not correct, correct me. But that's kind of how I think about it in my brain. Then we did a bit with object detection, which is basically like a self-driving car. Like you want to recognize other cars, people on bikes. So there's an algorithm that is relatively recent called YOLO. Millennials, I don't know, naming things, but it's basically for you only look once, and so you basically take one look at the image and then run your network, and it will detect all the features that you're interested in instead of having to do it one at a time. One benefit of that is that you can share features, so as it learns one thing, that might help it learn another thing. So then we did another project that week on face recognition. And so there's a difference between face verification and face recognition. One more thing is neural style transfer. This was actually the funnest thing that I learned. Neural style transfer is interesting because you can basically take an image, take a style of another image, and squish them together, and then you get your output. So that is what I'm going to show you that I did. So this is the actual project. So you're basically taking this picture with this picture and getting out this picture. Here is my base image. There's Marissa and myself and Hudson. And we're gonna convolve it with this image. This is a picture of a painting that Marissa did. And then the result is this. So it was actually really fun. That is what I've been learning these past 2 weeks. CNNs are really interesting, but it's not in my typical area of interest. So while it was very cool and interesting to learn, I am excited for the next course, which is sequence models. And I shouldn't try and squeeze all this stuff into like one talky video. It makes it kind of boring, I think. But anyway, let me know what you're learning, and we will see you like in a week or so.